Cartesian coordinates to these polar coordinates with r and theta. So you'll need to know this, that if you're going from rectangular or Cartesian to polar or circular coordinates, the x is r cos and the y is r sine. And the other thing is that the little area element is, and you can look at the lectures to see where this comes from, it's r dr d theta. This will, you need to kind of learn this, to be honest with you. Okay. So we're going to add up the contribution to this infinite sum along a spoke at a fixed angle theta. So contribution from spoke. So this is a sum over the whole region, and the contribution from this spoke is to add up from r equal to 0 to r equal to the radius, which is 2, y, which is r sine theta, dA, which is r dr d theta. Okay. Now what's very important is along this spoke, now d theta, this is actually a very, very narrow pizza slice, and d theta is the angle that the pizza makes, and that's constant, and theta is constant, so we can take out everything that isn't r as a constant. And we're left with the integral from 0 to 2, r by r is r squared dr. Okay, and this is an easy integral because the antiderivative of r squared is r cubed over 3. And we want to do top limit minus bottom limit. So that's sine theta d theta 2 cubed over 3 minus 0 cubed over 3. So substitute in top limit minus substitute in bottom limit. And this is 8 over 3 sine theta d theta. So that is the contribution to the sum from this this spoke or pizza. I think it's better to think of it as a spoke. Now what we have to do is add up the contribution to the sum from all the spokes, and we've got a spoke at an angle theta equals 0. To add up all of the contributions from all those spokes from theta equals 0 to when you get over here, the angle is 180 degrees, which is pi. So if you're adding up over the whole region, y dA, we've got the contribution to the sum from a single spoke, and now we need to add up the contribution from all those spokes from theta equal to 0 to theta equal to pi. So we can anti-differentiate here. We fix the constant 8/3, and you look in your tables, so I'll have to be sending you tables, the big full tables. I'll send you a PDF copy. Antiderivative sign is in there, it's minus cos of theta. And now we do top limit minus bottom limit. So this is 8/3 by minus cos, so that's minus 8/3. Top limit cos of pi minus 8/3 cos of bottom limit, which is 0. And if you bang this all into the calculator, you will get 16/3. And therefore, the y coordinate is this integral that we've just calculated, which is 16/3, divided by the area, which is 2 pi. And now we will do the calculator. So I have 16/3 all divided by 2 pi, and it comes out as approximately, let's do something about significant figures. No, so we'll just do 4, 0.8488. Now there's something I missed on the previous question, and we'll do it here though. Okay, so we've calculated this and then indicate on your sketch. So if this is 1, it's a bit less than 1, so something like this. So the x coordinate is 0 and the y coordinate is approximately 0.85. As you'd expect, it'd be slightly less than 1. Okay, now something we didn't do with the previous question that we should do here is ask, after you've answered the question, you say, have I answered the question that was asked? And does my answer make sense? So looking at the previous question, the question asked us to solve the system of differential equations, and we did that. Did our answer make sense? Well, I probably need the answers in front of me to do it properly, but basically what you had was that both of them were negative exponentials, and that meant that they're both going to 0. And what you have to understand in the previous question now, not this one, is you have water flowing into a salty brine tank. That's flowing into another salty brine tank, which is flowing out. If you keep flowing fresh water into this thing, the amount of salt, which is in the first, which is x, and in the second, which is y, that will go to 0. The other thing you'll notice in the solutions is that every bit of salt that, it's probably a bit harder to see this, but that left the first tank went into the second tank. That's probably actually forget about that bit. Okay, so yeah, in the previous question, we answered the question that was asked and the answer made sense. Here, did we answer the question that was asked? Did we roughly sketch the region? Yeah, it's not a bad sketch at all. You might want to get graph paper. You don't need it, you can always draw on whatever you got. I'll never ask you to do an exact graph, but it might make things a bit easier. Did we sketch the region? Does it make sense? Yeah, it says semicircular disc, that's what we got. Where x bar, y bar is the centroid, write down x bar. Did we do that? We did. Did it make sense? Well, it had to make sense, that's where we got it from. Did we calculate y bar? Yes, we did. Did the answer make sense? Yes, because we would expect it to be below 1, and it was. And indicate on your sketch the position of the centroid. We did that. Does it make sense? Yes, good. Okay. Now it's going on about SI units there, so if you wanted, you could, throw these in, but I don't think it's actually important at all, this question. Right, so that's the other possibility here is that you have maybe a rectangular shape or a triangular shape. There's other possibilities here, but because this one was circular, question B will now be a rectangular coordinates, which is easier. You don't have this. Any questions, as usual, you can just email me. Okay, now we're going to do 3B. So here we have a box given by, so the x's go from 0 to 2, the y's go from 0 to 3, and the z's go from 0 to 4. So our box looks something like 0 to 2 along the x, 0 to 3 along the y, and 0 to 4 along the z. Okay, so this is what we're dealing with. For this box, calculate the mass. So there's a formula given, so it says there's a triple integral over the box. So we're going to add up over the box the density, and that's presumably per unit volume by dV. Now everything's a bit easier here because we're in the rectangular, there's no change in things. Okay, so what we're going to do first is we're going to fix the height and the y coordinate, and we're going to find the mass of, spoke probably isn't the right word, a rectangular bar. Okay, so just it's gone from one face to the other. The distance along the y is fixed, the height is fixed, but the x is going from x equal to 0 to x equal to 2, and we'll find the mass of that little thing. So the mass of, we'll call it a bar here, is you add up from x equal to 0 to x equal to 2. What are these things? So rho is 2x squared y squared z cubed. And dv here, well, in rectangular coordinates, it's dx by dy by dz. Now if you look at this, the cross section of this little bar here, it's dy and dz, they're constant. And also it's at a fixed height, so z is a constant, and it's a fixed distance along the y, so the y squared is a constant. Of course the 2 is a constant. So what you can do is pull out all the constants. So 2 is a constant, x is not a constant here because x is going between 0 and 2. Take out y squared, z cubed, dx stays there, dy dz, and you're left to integrate from 0 to 2 x squared dx. So the actual integral here is pretty straightforward. So we got all this stuff. Now what you can probably do, what would probably be clever here, you could just kind of name this something, say star, and just write star. I won't be so lazy, but you could do that. I mean, you don't have to write this out every time. So you could just say, let this be star, or let this be L or something, whatever. So the antiderivative of x squared is x cubed over 3. Going from 0 to 2. Now, one thing to look out for is when there's a 0, don't assume you automatically get a 0. So for example, cos of 0 here is actually 1. So just be aware, just because there's a 0 here, it's not definitely going to give you a 0. It does in this case, but not always. So now we must do top limit minus bottom limit. So that is 2 cubed over 3 minus 0 cubed over 3. And this is 8 over 3, 8 by, do them right here, yeah, 8 by 2 is 16, so 16 over 3 y squared z dy dz, and that's the mass of one of those bars. Now if we add up all those bars, say from y equal to 0 to y equal to 3, those bars, almost like floor beams make up the floor, all these bars, if you add up from say y equal to, add all of the fixed height, y equal to 0 all the way up to y equal to 3, it's like the mass of a floor, or I'm going to call it a plate, and they go from y equal to 0 up to over here at y equal to 3. So if we add up this from y equal to 0 to y equal to 3, we get the mass of a plate. Now because the space, I'll start down here. So the mass of a plate is found by adding up the masses of all the bars from y equal to 0 to y equal to 3. And we're talking the mass of a bar is this, 16 over 3 y squared z dy dz. Now along the plate, z is constant and dz is constant. Actually the way I drew this was wrong because that'd be dy and that'd be dz. And so when you're going across like this, this dz is constant. That'd be like the width of the plate. So take out your constant, 16 thirds. You can take out z and dz, and you're left with the integral from 0 to 3 y, was it always y squared? Oh, messed up the question, right? So this x squared is supposed to be x. Maybe I'm better off fixing it in case someone has tried this question themselves. So this should be x. This should be x, this should be x squared over 2, this should be 2 squared over 2, and therefore this should be 4. Sorry about that. So taking this out, that's a 4. Okay. And now we've got y squared dy. Now this is an easy integral, so you got 4z dz, integral of y squared is y cubed over 3. And we're going from 0 to 3, top limit minus bottom limit. So it'll be 3 cubed over 3 minus 0 cubed over 3. 3 cubed over 3 is equal to 9. 9 by 4 is 36, so we've got 36z dz is the mass of this plate. and then add up all the mass of all the plates from the ground floor, as it were, z equals 0, up to the top, z equals 4. So get that the mass of this box is add up from z equals 0 to z equals 4, 36z dz. So fix the well, no, we can just anti-differentiate away here. The antiderivative of z is z squared over 2, and fix the 36, so you get 36 z squared over 2 from 0 to 4, just do top limit minus bottom limit. I'm going to do 36 over 2 is 18, so 18 4 squared minus 18 0 squared, and 18 by 4 squared, 18 by 16, 288. The question says assume SI units, and the SI units of mass is kg. Okay. Now again, have we answered the question that was asked, and does our answer make sense? For the box, calculate the mass. We did that. Does the answer make sense? It's probably a bit difficult for us to say whether this makes sense or not as an answer. We can't really. I mean, you could take maybe the midpoint and kind of multiply that. You know, that'd be a rough thing. So, like, are you in the right ballpark? Look at 2. So the density is 2xy squared z cubed. So 2. The middle x value is 1. The middle y value, this is not accurate, it'll just give you like to the nearest order, kind of the multiple of 100. Not even that, is it a multiple of 10, a multiple of 100, etc. The average y value is 1.5, and the average z value is 2, and that gets cubed. Then multiply by the volume is 24, and I get 864, which is a multiple of 100, suggesting this is correct. The reason that's not accurate is because, say if you take z, not the average value, well actually the average value of z in here is 2, and you cube you get 8, but like up the top it's way heavier, it's like 4 cubed is like 64, so that's why that calculation is given a gross overestimate. Okay, so that's that done. So the other way that this can fall is that you get a rectangle or a triangle in the first question and a cylinder here. Okay. The last question then is the undetermined coefficients. Now in the undetermined coefficients, you're going to get one of them which is looking for the general solution, and the other one which is looking for the specific solution that's got initial conditions. Okay, but they both kind of start off the same. This is back on page 227. So now you cannot use Laplace transforms here. It'll say using only the method of undetermined coefficients. Okay, so the equation that we're looking at here is, well, it's written there on top of page 227. Second derivative plus twice first derivative plus 5 times the function is equal to a constant. So how you solve these is first you solve them equal to 0. So you got y double dashed of t plus 2 times the first derivative plus 5 times the function. First you solve it equal to 0. This is true for both of these. First solve it equal to 0. How do you solve this? You form what's called the auxiliary equation. So this is 1r squared plus 2r plus 5 equals to 0. You have to solve this. Now after doing Laplace you should be quite good at factorization. Well, you can use the minus b formula here, I suppose, because you will at this point you won't need to factorize anymore. No, so you could just go into the minus b formula. So r is equal to minus b minus 2 plus or minus square root of b squared, which is 4, minus 4 by a, which is 1, by c, which is 5, all divided by 2a, 2 by 1. This is equal to minus 2 plus or minus, now this is 4 minus 20, which is minus 16. Now, do not change that. Be careful here. Square root of minus 16, there's no real number that squares to give you minus 16, so you're into the imaginary numbers here. So what you have to remember is that square root of minus something is I times that square root. So this is minus 2 plus or minus I times square root of 16 over 2. And then the square root of 16 is 4. So we've got minus 2 plus or minus 4i over 2. And then divide into 2. Minus 2 divided by 2 is minus 1 plus or minus 2i. Now the good news here is that if there are complex roots, then so the solution of this is called the homogeneous solution. And if the roots of this are complex, so there's 3 different cases. If they're 2 different roots, obviously you'll have to do a revision on this yourself. But if they're 2 different roots, 2 real roots, you get 2 exponentials. If they're equal roots, it's like a rule 2, like critically damped. You get an exponential and then t times an exponential. With the complex ones, you get the sines and the cosines, and there's quite a complicated formula, but it will be on the question paper if you need it. So here it was on this question paper. It says that if the roots are p plus or minus iq, then